Thank you for joining the Waterfront webinar on progress to decarbonisation of rolling stock. My name is Rob Clayton. I'm from IPEX Consulting and I'm the chair for the webinar today. So it's an hour long, runs from 10 to 11 o'clock, and it will be recorded. So if you join late, you can watch it back. We have two really good presentations being delivered from Julian Fletcher from Viva Rail, who'll go first, and then Mark Gaynor from Rail Partners will go second, and then there'll be an opportunity for Q&A. We can't see any of you, you can see us. So the way to ask questions, if you use the Zoom Q&A function, that would be great. There's a Q&A function and a chat function. So use the Q&A for questions, and feel free to use the chat to make any comments or observations as you wish. So before I introduce Julian, the first speaker, I'd just like to really set the scene about the subject. So some of you may already know that rail in the UK makes up 1.4% of transport CO2 emissions, and to put that into context, pre-COVID passenger levels meant that rail carried 10% of all transport passengers. So already rail is a very green form of transport. I think it's fair to say that modal shift would certainly help decarbonise transport itself. But we can't rest on our laurels. We need to still decarbonise our rolling stock to keep up with other sectors as they find alternatives to fossil fuels and decarbonise their assets as well. We must also ensure that we run our network at full capacity. Running empty trains around is also not good for the environment, and will certainly push up the 1.5% figure that we like to bounce around as a sector. I think we also need to think about clean air for passengers, stations, and obviously rail workers at depots as well. When we think about decarbonisation of rolling stock, that is another significant benefit. We have some big targets. We have the 2040 target, which has been set by our sector to remove all diesel-only trains from the network. And then, of course, we have the UK 2050 net zero target as well, 10 years later. So the status of our network at the moment, it is said that electrification is the most efficient way to decarbonise our network. In the UK, we have 42% of our network electrified. To put that into context, Germany is around 60%. I recently read an article about Germany that said they were lagging behind their partners in their neighbours, in Europe. So, for example, Switzerland, Belgium, Netherlands, and Sweden are around 70 to 100% electrified. So, UK is even lagging behind that. The TDNS, Network Rail's Traction Decarbonisation Network Study, identified that we have around 15,000 single track kilometres unelectrified, and to achieve the net zero target, the net zero 2050 target, we need to electrify around 13,000 kilometres, and the rest should be covered by self-powered diesel alternatives like battery and hydrogen. So over the 27 years between now and 2050, that equates to around 480 kilometres per year on average. And interestingly, that is a similar distance to that's committed for the Transpennine route upgrade and Midlands upgrades in the integrated rail plan. And as an average per year, that is quite a bit more than what we have done, certainly in the past decade. So it's fair to say that we need to get a move on and improve our capability and accelerate our delivery of electrification. In the meantime, we still need to run trains on non-electrified lines. We still have a few thousand diesel-only vehicles operating in Great Britain. Some of these will naturally life expire before 2040 and certainly 2050. But interestingly, some entered service quite recently. Some are still entering service now, and many entered service in the last decade. So will still be midlife vehicles by the time 2040 comes along. So we have a huge challenge ahead of us. We have a challenge to decarbonise some of our existing fleets, and we also need to consider alternative types of rolling stock that need to be procured as well as our existing fleets life expire. So that's the challenge ahead of us. We're talking very much in the context of passenger and freight, and we're talking about the challenge in the UK, not globally, although we're happy to discuss some global examples as well. So that just sets the scene, and without further ado, I'll introduce our first speaker today. That is Julian Fletcher, Technical Manager from Viva Rail. Julian is a Technical Manager at Viva Rail, designer and manufacturer of the UK's only battery and hybrid battery trains, able to provide unlimited emission-free travel off the rails. A pioneering engineer who spent over 20 years working within the aerospace industry, Julian made the decision to join Viva Rail in 2020 with a passion to make a genuine difference to both the rail sector and the environment. Now at the engineering heart of the UK's battery train industry, Julian is working on the final stages of demonstrating fast charging technology at Viva Rail, which will enable battery trains to have practically limitless range. So without further ado, over to you, Julian.
All right, thanks, Rob. Yeah, so I'll just share my screen and take folks through some material I've got to present. Okay, so we'll start off with a little bit about Viva Rail itself and what we do. So Viva Rail was incorporated in 2013, and the intent there really was to provide a bit of impetus to innovation in the rail industry, headed up by Adrian Shooter. And since that time, the headline figure is that we've designed and manufactured 5 different types of train in 5 years of that order. So we started off with providing diesel electric units, which were converted D78 stock, which is probably what we're most well known for. But as a company, we will convert any rolling stock, really. And we've moved from that position to becoming battery experts via hybrids, third rail, and most recently, and probably most well known, would be the 3-car train, which we took up to the COP26 conference. And very recently, we're just finishing off our work in readiness to run a fast charging demonstration, as well as working with Eversholt on the 321 Renatus 25 kV battery hybrid. So a little bit about battery trains. They get talked about as if they're new or pioneering. People may know that the first lead-acid battery train was around 100 years ago or something like that, but we've been running battery trains for quite a while now and have a lot of confidence in the technology. As I mentioned, we ran the train up at COP26, and we were carrying passengers daily there, and that was with an overnight charge because we didn't have the fast charging system on there. But that's the first self-powered non-diesel to run across the Forth Bridge, which we're delighted about. And we the Transport for Wales have a diesel, electric and battery hybrid, which they've got thousands of miles on those, and that's like a geofenced air quality version of the technology. So onto the fast charging system. Now that's really the technology that underpins the viability of batteries for traction on trains, and that's for converted or otherwise. So it's well known that if you put some batteries on a train, you will have a range limitation. There's a mass limitation and there's a volume constraint under the train. So you will have a finite range you can sensibly work with while you respect the minimum capacity on the battery. You don't want to run it completely dead all the time. You want to run it down to say about 20%, make sure you preserve its life. So the reason that this has now taken off is because the battery technology is at a stage where we can fast charge them, and we have a fast charging system that can do that. So you combine those two together, and providing you can produce a safe, reliable system where the driver doesn't need to do anything, it's fully automatic, then you're in business and you can start to operate a normal timetable and nobody would know any different. Now, certainly the passengers may notice that there's less noise and certainly the air quality will be better, but other than that, things work on time. So back in 2019, we did the very first technology trial. That was an Innovate UK funded piece of work, and that just used a third and fourth rail, that's that picture on the right, to pick up off a couple of charge rails, and that just shows that the whole thing can work safely and fully automatically with the rails covered by a vehicle. That's moved on considerably now. So the production fast charge system uses a trackside battery bank so that you can trickle charge that from the grid or from your renewables in a field full of solar or whichever power supply you choose. And if you're aware of these things, that it's a conventional battery energy storage system. It's just a container full of batteries managed, and then we have a front-end interface on that to connect to some charging rails. So you could well use it for trading electricity or softening the grid supply and managing peaks to local community, EV charging, all the rest of it. But in this case, we put a front-end on it so that when the train comes along, the interlocks can talk to each other, make sure it's the right train in the right place, and it does want to take charge. The train features some specialist shoe gear beneath it, which come down, contact the rails, charge up, and away you go. Now, that system will be operating from West Ealing to Greenford with GWR later on this year. So it's worth also touching on the embedded carbon emissions and the operational carbon emissions. So we talk about heading to zero emission progressively. So depending on where you get your electricity from, if you get a full renewable supply, then you can argue that you're at zero emissions already at point of use. If you use UK average grid, then you'll be following the graph on the left there. And you can dial that into your operational emissions calculations. But we calculate the embedded carbon emissions of our converted vehicles routinely. That's part of the process of designing and engineering it. And you can see the graph on the right. That first bar for a 2019 operation, by way of example, includes the embedded emissions, and then once those are accounted for, then the operational emissions just track down progressively year on year. But it's worth putting this in context. The embedded emissions for a modified vehicle would be the same as is produced by a diesel, like a DMU, in about 3 months. So it's that kind of rate. And doing a reworked vehicle, a modified vehicle, is about half of that of a new vehicle in terms of embedded emissions. So yeah, you would imagine quite correctly that there are enormous opportunities to do this across the country, where you've got DMUs operating at the moment, and you've got a modest grid supply, and you don't really want to spend the money on electrification. Passenger numbers might not warrant it, or it may be the case that actually there's also scope for the trackside battery energy storage of a fast charging system to be used for other things. So we're looking at many opportunities across the country where fast charging battery trains can operate, and they're extremely viable and economically attractive. So part of the remit behind the engineering of the fast charging system was to make it almost tortuously compactly packaged, and I have a great thanks to my chief engineer at the time to be able to do that. But that's what we've done. So that same system can be packaged onto converted locomotives for shunting operations and yellow plant as well. And we've done several feasibility studies, and we have some serious customers lined up for some of those vehicles. So this isn't it's not specific to passenger rolling stock. It can be applied across the board. The fast charging system, because of its automatic nature, is very attractive for people running depots, quarries, that sort of thing, because there's no need to plug in. You just position the vehicle in the right location, and everything else happens. So to summarize, really, the battery traction and fast charging system is available right now. We've got the trial with West Ealing happening later this year, but it's designed and it's ready to go. And it's a very low carbon way of operating. The embodied carbon is low, operational carbon is low, and it does support recycling and a circular economy, including the batteries used on the train as traction batteries and those in the trackside storage system. You can move from one to the other for second, third and fourth life batteries, depending on how you manage them. So that's the end of my presentation, and I'd very much welcome questions if anybody has any, but I think now we're handing over to Mark.
Yeah, that's right. Thanks, Julie. We'll leave questions till the end, so we'll go on to Mark next. So I'll just introduce Mark. So Mark Gaynor, Director of Operator Services at Rail Partners. Mark is the Director of Operator Services at Rail Partners, the new trade body for train operators. Mark's team provides engineering and operational services to passenger train operators to help them deliver safer, more efficient and more reliable services to customers. Mark also leads on sustainability within Rail Partners and was a member of the Rail Industry Decarbonisation Task Force, which developed a vision for how the railway can fully decarbonise. Prior to joining Rail Partners, Mark was the head of railway strategy at the Rail Delivery Group, and before that, worked in a variety of roles at the Department for Transport. Over to you, Mark.
Thanks very much, Rob. Morning, everyone. I haven't got any slides. I'm just going to talk, but I wanted to build actually on some of the comments that Rob made at the start of the event, and to sort of look at the progress we've made as an industry over the last sort of few years on decarbonisation and some of the challenges we're going to face going forward. And for those of you who've been, like me, been around a bit, you might recall that it was back in early 2018, so about 4.5 years ago, that the rail minister at the time, Joe Johnson, set that ambition, Rob mentioned at the start, to remove all diesel-only trains from the network by 2040. But as part of that, he also challenged the industry to sort of set out a broader vision for how it would fully decarbonise. And I think the minister's challenge was sparked in part by all the progress he had seen being made in the automotive sector. And I see we've had a question from Mark Loather about the fact that if we have lots of electric cars on the network, actually their carbon performance will look pretty good compared to running diesel trains, for example. So I think that's that sort of fact, that emergence of electric vehicles really did influence sort of the minister's views about, oh, okay, the railway ought to be upping its game given progress in other modes. And that challenge from Joe Johnson, that resulted in some really good and intensive cross-industry activity through the Rail Industry Decarb Task Force, then Network Rail's Traction Decarb Network Strategy, and both of those bits of work then influenced the DFT's Transport Decarb Plan. I think the really positive aspect of all of that work was it showed it was feasible to decarbonise the railway. We didn't need lots of new technical developments. We had the sort of different technologies we needed, primarily through further electrification and then sort of targeted use of battery and hydrogen trains. But what we don't have, still don't have, is a clear delivery plan and the funding needed to sort of make it all happen. So I think where we're at the moment is really waiting to see what emerges from all the work going on to develop the whole industry strategic plan, the WISP. I think hopefully many people on the call will be aware of that. I think the name may change, but it's being developed by the Great British Railways Transition Team for the Department for Transport, and ultimately it's going to provide government ministers with options and choices around a long-term strategy, and as part of that, it's going to provide options and choices for ministers about different levels of ambition around decarbonising the railway, what those look like, how much they might cost, and the relative benefits and affordability. And what I certainly hope, and think what probably many of us on this call hope, is that it will result in a clearer and sustained government commitment to decarbonising the railway, to rolling out electrification, and some of the other technologies, including the things that Julian's mentioned earlier. And I don't think we necessarily need to have electrify huge swathes of the railway every year. I think really what we're hoping for is a longer term commitment with a sort of steady, affordable and deliverable programme of electrification, like they've had in Germany. I think that was mentioned earlier by Rob, and it just involves electrifying a steady amount every year, but year on year, and that then gives suppliers confidence to invest in people, in skills, in kit, and hopefully enables suppliers to reduce the cost of delivery. And I think it's also true to sort of perhaps worth just noting that, yes, the rollout of all of these technologies is really positive from a carbon perspective, but delivers so much more than that. Some of the work that I did in RDG, and Rob in fact was involved in some of this, was looking at wider benefits around things like job creation, air quality benefits, but wider benefits around sort of speeding up journey times, reducing noise, improving reliability and cutting costs. So I think there's all these wider benefits that I think collectively we as an industry can get behind and really sort of showcase. This is not just about carbon. Yes, carbon's really important. There's all these wider benefits, which really adds to the business case for electrifying and for rolling out other technologies. Now, I think that the big challenge I see is that given the financial constraints that the government's operating within, there may not be huge amounts of new money available for sort of big electrification schemes. And if that's the case, then I think we have to look a bit more creatively at how we make better use of the rolling stock we've already got, the extent to which that can be modified, to sort of whether it's sort of a hybrid approach, so you've got sort of energy storage on it, or bi-moding, so it's able to draw electricity from where it's available, and also how we can electrify in a sort of a more cost-effective way, targeted electrification, discrete electrification, that can sort of deliver a really big bang for buck. But as well as the challenge around funding, I think we also want to make sure that the investments that we do make are future-proofed. We don't want to end up wasting lots of money on a new rolling stock, for example, which then can't be used because inevitably new rolling stock has a pretty long life, 30-35 years, and if you make the wrong choice, then that really is not a good value for money. So what I've been really pleased to see, though, is that even without guaranteed plan, guaranteed funding, a huge amount of innovations been going on in the last sort of 4.5 years. Julian sort of talked quite a lot about the work that Viva Rail's been doing in this space, and we've also seen developments elsewhere, sort of the Hydroflex hydrogen train that Porterbrook and Birmingham produced, Hybrid Flex, which is a sort of joint venture between Porterbrook and Rolls-Royce and Chiltern. But lots of other really good examples showing that we can move away from just demonstrations and pilots to something a bit more substantive in terms of rolling out these new technologies. And an announcement that was made, I think it was just over a month ago, by Network Rail, didn't capture a huge amount of headlines, but I think it's really important. It has to do with decarbonising our traction electricity supply. So Network Rail sort of indicated it was minded to procure up to 1 terawatt hours of renewable electricity per year through a power purchase agreement, which is about a quarter of the total traction electricity supply. So I think it's really positive. That would be additional renewable electricity and help to further the railway's green credentials. So final thing I just wanted to talk about was the fact that, yes, it's really important that we do decarbonise our rolling stock and our traction supply. And this is a point Rob did touch on, we do also need to encourage modal shift to rail, both for passenger and freight. We do have spare capacity, so there's opportunities to sort of use that spare capacity, encourage more people, more goods, more freight to sort of transfer to rail. And I think there are some fairly straightforward ways we can help to make that happen, making sort of the fare system simpler, ensuring train operators have the right incentives to grow business, bit of targeted electrification around sort of the freight network to enable more low carbon electric freight services to run. And I think for the policymakers out there, I think there has been a tendency in the past to think about rail as a mode in isolation. We need to move away from that and have a more holistic approach to transport making, so that we're thinking about how the whole transport system works together, and we've got the right incentives and policies in place to encourage a bit more active travel, cycling and walking, and encourage the use of public transport over the private car and the truck. So I think, we're in a good place. We've made a lot of progress as an industry. I think we're all keeping our fingers crossed to see what emerges from the whole industry strategic plan. But I think we're going to need to be sort of quite flexible and adaptable. I suspect there's not going to be a huge amount of additional money flowing into this over the next few years. But we do need to make progress given what other modes are doing. And that's it for me.
Great, thanks, Mark. That's some really good points there. A couple of quick questions from myself, actually, before we go on to the Q&A. In terms of what GWR are doing and the WISP, as you touched on, do you think we'll start to see a more robust long-term rolling stock strategy that's aligned to infrastructure upgrades such as overhead line as well as ETCS, so that we can have confidence in investing in new rolling stock that's not going to be obsolete when the wires are put up?
So I think that's probably what has been sort of lacking throughout all of this, is that we can't think about decarbonising rolling stock in isolation. It's part of a whole industry change programme. So we need to think about, for example, where electrification is going, where digital signalling is being being implemented. How does that align to rolling stock life, rolling stock cascade, procurement of new rolling stock, and of course where operators fit in all of this. So there's a big sort of culture change piece here as well, making sure we've got all of the right sort of skills and are able to run and operate and maintain whatever technologies are introduced. And I think that's very much why sort of Great British Railways was envisaged, to provide that sort of whole system sort of guiding mind. And from what I've seen, part of what the WISP process is doing is trying to bring all these different strands together, so we do have a coherent overarching strategy.
Great. And do you think there could be a risk as we get closer to the 2040 and 2050 targets? Do you think there could be any risk of the sector trying to offset carbon rather than genuinely decarbonise?
I'd be interested in other people's views, including on the call. I think there is that risk. I mean, I'm sort of quite optimistic that a huge amount of effort is going into looking at how we can decarbonise cost effectively. The opportunities perhaps for the use of biofuels, for if we can't get rid of all of our sort of diesel only trains. But it's 2040 in rail terms is not that far away. Again, when you think about existing rolling stock fleets we have, and the amount of time it takes to both bring in new rolling stock and introduce electrification, so it's a pretty tight time frame. Even though it sounds quite a long time, 18 years, it's not that far off. Yeah,
I agree. It's not that far off. We had a question actually from Mark Lover about the 2040 target. I think it's a really good point. It does need some further clarification. I think it not actually set in legislation, unless I'm mistaken. It is simply a target set by Joe Johnson. So have you got any thoughts on that, Mark, with that moves on to become more concrete?
It's quite a good point. If you just run your effectively diesel train 1 mile on a battery, then it wouldn't be captured. So I think it needs to be sort of thought about, not just as the ambition around diesel only, but the broader ambition about how we decarbonise the railway completely. We don't have that strategy at the moment. There's been some really positive noises from government in the past. I thought the transport decarbonisation plan was very, very positive, but until it's sort of backed up through a clear delivery plan, it does seem to remain sort of more warm words. So I really do hope that we get something pretty tangible emerging, and something also that's got sort of cross-party support. This is a long-term ambition, and it needs to get support from right across the political spectrum if it's going to have any chance of succeeding.
Yeah, great. Thanks, Mark. We had another question from Mark Lover as well about the 1.5% figure. This can be misleading. I think it's also a good point, and the point I was trying to make earlier is that I think as other sectors, particularly the car industry, starts to decarbonise with electric vehicles, that 1.5% figure will clearly go up, as will the figure per passenger mile if we don't utilise our capacity. So interestingly, if you look at the ORR data, the figure I quoted earlier, 10% rail passenger miles, is from pre-COVID. If you look at post-COVID, it's a lot lower than that. So if we don't fully recover in terms of utilising our capacity, then that 1.5% figure starts to become less of an advantage, I suppose, against other sectors. So yeah, really valid point. Some questions coming in on Julian's presentation about battery technology. So we'll just look at those. See that, Julian, you've answered some of them, but for the benefit of the audience. So I had a question about how fast is fast charging at the station, and does it happen in passenger service? If I could just add to that as well, it'd be useful just to talk a little bit about what variable do you use to define the rate of charge? Is it kilowatt per minute or something like that? And how is that advancing over time? Is that technology showing improvements in that area?
Okay, so I think there's a bunch of questions all around this. So The kind of headline figure we usually talk about is 10 minutes to fully fast charge a train. Now, the engineers amongst the audience will pick up on that immediately and say, well, what do you mean by fully fast charge, and what's the range, and so on and so on. Well, it's the same as with an electric vehicle. It depends whether you're going up the Lickey incline, or you stopping every 10 minutes. But a sensible number is around 60 miles of range in about 10 minutes. And that means that you're, and we're charging at quite high power rates. It is around 1,000 amps we're putting through the charging system. Now, I think there's another question about, well, how's that physically working? Well, the charging rails at Great Western, they're about 4 meters long, and the safety remit is that they are significantly shorter than the vehicle, and they're fully covered. So you don't have access to the rails when they're live. They're only live when you're charging, and they're earthed throughout the rest of the time. And it really is, there's a set of rather tortuous interlocks that happen. So you can only have current flowing through those rails when the train's in position, the batteries want charge, and it's safe to do so. And there's a ramp up, as you might expect, to check that everything's connected properly and there's no debris between the contacts, all that sort of stuff. I'll just, if it's all right with you, Rob, I'll just rifle through some of the questions that are relating to fast charge. And
yeah,
I think somebody'd asked about the weight of batteries on trains. It's a very fair question. Now, I can speak in terms of converting trains, and weight. You do check it. Certainly, when you're looking at the installation of the batteries and other power electrical equipment, you do check that you're not going to significantly alter the center of gravity, because you really don't want to throw the kinematics off and mean the things are going out of gauge. But usually we run out of space before we run out of mass carrying capability. The strength is that there's generally enough capability in there. The question was about new trains, and it would come back to how you want to operate the whole thing. Because if you want to have absolutely massive range, then you'd have a very big battery, and then you would start to be looking at quite a high mass. But generally, on our DMs, we have 3 batteries on each one, 2 or 3 batteries, depending on the variant, and each one's about 1.7 tons. So that will give you some flavour for the numbers. So think about the future. Would other suppliers other than Beaver Rail be able to use the same? Absolutely. Absolutely, yes. So other people using the same fast charging system, Network Rail have said to us, make it work, set the standard, and make sure everyone can use it. So we can license out the shoe gear that goes on the trains themselves, but the whole system is set up so that anybody can use it. It's not exclusive to Beaver Rail. Something else that is worth mentioning, that in terms of electrification, the 25 kV 321 Renatus with a battery range extender on it, if you like, or that covers you for unelectrified sections, does lend itself to discontinuous electrification. And that's I think there's a question about areas where it's very expensive to electrify the route, and that's absolutely something Beaver Rail are really quite enthusiastic about. Let's cut the cost of the job and look at partial electrification of routes, and how the charging system doesn't become a problem. It's actually an opportunity to help smooth the supply to communities, because as Hayley points out, with the moving the climate, you do want to protect yourself from massive fluctuations and storms and problems with supply. I think Hayley also mentioned about alternatives like hydrogen, and I guess I would say that if you have a fast charging battery supply at the side of the railway, then certainly I think the one at West Ealing will supply the train. Although it's trickle fed, it supplies the train for many, many journeys. So you've got some outage protection, and I guess local communities may well connect into that. So it may well, in the very long term, as we start to look at what contingency we put in place for the change in the climate, this integrates with that. But very long term, I have no doubt that there's an incentive. Let's be transparent about it. The oil companies are absolutely behind hydrogen because it's a means of revenue earning as we transition to zero emissions, so they can produce, how should we say, high carbon hydrogen, if you want to call it that. But and the money behind that is vast. So it's worth being aware that hydrogen will always be backed, and it certainly has a place in the future. You can have enormous amounts of battery storage and hydrogen storage, and then deal with the peaks and troughs of renewable supply. I mean, it's always good to have an additional option, and there's complications with hydrogen, but I have no doubt that they would take longer to overcome, I suspect, and batteries sort of here and now. Let's go. Let's meet our emissions targets and try to protect our 1.5 degrees. But hydrogen will have a place to play. I suspect we're talking the sort of 10-20 year time frame. Sorry, I hogged that a bit. Other questions for you, Mark?
That's a good point. Just touching on the question from Hayley Warrens. Thank you, Hayley, for the question. I think it's a good question. What is being done to innovate low carbon solutions? And hydrogen is a good example. Mark touched on a lot of innovation in the UK. I was at Intertrans last week, and I was blown away by the cutting edge technology that's now on display. It seems we've moved at an incredibly fast pace from reading about these technologies in magazines to seeing them and almost reaching a point where you could order them off the shelf. There's many hydrogen and battery products now available. I think that the key with these innovations is to truly understand the end-to-end generation of the energy. So taking hydrogen as an example, there's different coloured hydrogen. You can have green, blue, brown hydrogen. Clearly, with the best for the environment is green hydrogen because it's been made from a sustainable supply. Brown and grey hydrogen still puts some CO2 into the atmosphere. So I think we need to be careful not just to move the problem somewhere else. While politically and the perception from the public is that hydrogen is very green, and sometimes it's not. So I think we need to understand that. And I'll just bring Mark in. I think one of the challenges of introducing hydrogen will be the infrastructure that's needed to supply the trains. So I think again that might need longer term vision and intervention from government to make that happen. Is there any thoughts on that, Mark?
So clearly sort of introducing a new fuel brings with it certain logistical challenges, for example, around how you transport it, how you store it, sort of various sort of safety issues as well. Not that it's sort of inherently more dangerous than diesel, but it just has sort of different characteristics, which means it needs to be treated in a different way. I touched on the fact that we need to think about this as a whole industry change program. So yes, there will need to be development of appropriate standards and training to make sure that everyone is able to deal and manage the risks associated with hydrogen in a sort of considered way. So for example, what does it mean for the design of future depots and sort of maintenance facilities? All of that sort of needs to be thought through. And I think to date, most of the thinking has been done at sort of quite a strategic level. Where should electrification be? Where should hydrogen go? But at some point, it really does need to sort of get into the weeds about what does this all mean for the design of rolling stock, how it's driven, how it's operated, how it's maintained. And I think we're a little way off from that. But hopefully, things like the various trials and pilots going on will help to inform those processes. I just wanted to comment on, there was a comment from Hayley about, just going back on a comment about climate change. I think it's a really good point that whatever we do, we really need to test it through different lenses, one of which must be, is it resilient to expected climate change? So if we are designing electrification, it needs to withstand future weather conditions, which we do expect more extreme weather. So I think that's a really good point that sort of Hayley made. And having our own electricity supply as well will help to make things sort of more resilient. And just picking up sort of Mark Lowther's point about whether the TD&S strategy of electrification is affordable. Electrification makes both sense on sort of busier routes where you've got sort of a high throughput of trains that sort of can offset the sort of capital cost of the infrastructure. So it doesn't make particularly good sense on lightly used routes where you've only got a few trains an hour. And as I mentioned in my presentation, the fact that there is probably going to be less money available means we're going to have to cut our cloth accordingly, and perhaps that balance between full fat electrification, discrete electrification, hydrogen, hybrid, and battery powered trains, we'll need to sort of adjust the dial depending on the money available. And that's exactly what the WISP team is doing at the moment, looking at those different options depending on how much money is available. So yeah, absolutely, Mark, good point.
Yeah, just touching on that as well, there's a comment from an anonymous attendee that Transport for Wales are currently installing discontinuous electrification. That's right, and I think it's a good example of where we've really got a good interface between track and train, new trains being procured with a secondary traction with batteries, and discontinuous electrification, which hopefully should reduce the overall capex of the project. So a good example there.
Shall I just touch on the questions from John and Sean there?
Yes, please, Julian.
So as excellent questions. So drawbacks of fast charging versus slow charging batteries. Now, we use lithium iron phosphate technology, which is most resilient in terms of sort of long-term cyclic life, but it's not as power dense as lithium titanate, lithium manganese, and the other more exotic chemistries you've got in EVs. However, the combination that you need to start really degrading batteries is charging them fast and at extremes of temperature, either hot, too cold. So what we have is we've partnered up with Hopeki, they've come up with a rail battery pack where they're pouch cells and have closed circuit high rate of cooling over those cells, so they are thermally managed to a really fine degree. So that's how we managed to do it. But it is a very good point, and if that wasn't the case, they would degrade. Now, it leads very nicely onto Sean's point about, well, raw materials and low carbon mining to actually make the things in the first place. So there are papers out there, studies on the carbon associated with the batteries in the first place, and that is included in our carbon accounting. However, that doesn't really deal with the longer term issue. Now, there's constantly pushing for further battery chemistry changes and more sustainable ones. The most recent one is a sodium-based chemistry, which it's set up to be a direct competitor for lithium iron phosphate to produce the same energy density and charging capability, but at a reduced price and using sodium, which is much more easy to get hold of. I suspect that'll take off, and there are customers for that, I think, in the States. So that I wouldn't be surprised if that starts to move into place. It's also worth mentioning that the technology that we use and that the batteries on the trackside units use is immune to battery chemistry. So it doesn't matter what it's given. And on the train, you've got a DC link that doesn't know what battery is being used. So we're definitely keeping our technology such that we can change to more sustainable battery chemistries as they arise. All that said, the proof that is coming to the fore is that the expectations over cyclic life for batteries were pessimistic, and we very much believe that there are second life applications already growing, certainly like lower demanding roles like the trackside battery storage or power station backup, all that sort of stuff, where ex-vehicle batteries get moved into those roles, and we see a natural progression from the vehicle to the trackside to home storage for PV cells and the rest of it, and then potentially recycling after that. So yeah, it is a good point, but I personally believe that there are moves afoot for other chemistries to take over from the sort of rare material versions.
Right, thanks, Julian.
I can see one about safety as well. Sorry.
Yeah, I'm just conscious of time. I think
I can answer that offline for
questions. I think just looking at there's a question there from Casper Lucas. Is there a figure for the post-COVID percentage of total passenger miles, which was stated to be a lot lower than the pre-COVID 10%? There is a figure. It is. So the latest, these are all available on the ORI website. The latest figure is the rail emissions accounted for, apologies, so 2.7% of all passenger kilometres were made using rail as opposed to the 10% pre-COVID. So that number's come down and largely driven by the reduction in passenger numbers. Passenger numbers are starting to recover. Some talks are as high as 80%, 90%. Again, the figures for that are available on the ORR website. So there's a big discrepancy depending on the demographic of passengers across the train operating companies. And I think there's equivalent figures for freight on there as well. Apologies, I don't know those off the top of my head. Should we come back to the question then, Julian, about batteries again?
Absolutely, yeah. And very good question. And I must admit, I do usually, when I'm talking to customers, that everybody asks about safety, and we are very hot on that. So there's a couple of issues really. There are existing standards for safety which we comply with. I think they are ENIEC 62928 and 62485, if you're that interested. However, we also look at that from an as low as reasonably practicable perspective for safety. And what we really do is say, well, the worst case is thermal runaway. It makes the headlines, and most people are aware of it. And that can be caused by about 7 different issues that can feed in and result in it. There's external heating, which we manage by having a thermal management system. There's overcharging and over discharging and high current charging. Those 3 can combine long term to form lithium plating and ultimately internally short the battery out. Overcharging, you can't really do that with the chemistry we use. So we've paid the price of reduced energy capacity with the benefit of not being able to overcharge, and also the events of thermal runaway with lithium iron phosphate batteries are less dramatic. The smoke, gas venting, flames and so on, they're much reduced, much more manageable than the higher energy capacity batteries. There's other things that you can do, so that there's crushing, structural damage. Well, you could do that and internally short the batteries, but they start to enter the realm of, well, what would you do if you had a diesel engine and you crushed that and got the exhaust next to the fuel supply? So that's designed out in terms of making the thing robust. But the other source is if you externally short the battery out, and that's dealt with via the electrical design, because as you might expect, externally shorting out a train that's pulling off the 25 kV, you'd have similar slightly spectacular failure modes. So those 7, sorry that was a whistle-stop tour, but there are 7 key routes that need to then develop through a series of failure cases to achieve thermal runaway, which makes YouTube. But each one is dealt with via either choosing the chemistry at a bit of a loss of capacity, or robust design of the power, electrics, and mechanics. Hopefully that's answered, but always happy to share these things.
Great, thanks, Julian. I think it's a great place to finish on a safety question. I think just to wrap up my thoughts, I think some great insights there from Julian and Mark. Thank you for your input. I think it's a really fascinating challenge that the sector faces, and I don't think it's a case of electrification versus battery versus hydrogen versus something else. It's not a one size fits all solution. So it's great that we've got all these different options to consider, and let's remain open-minded to the new technology as it evolves. So thank you, Julian, Mark. Thank you to Maxine and the rest of the Waterfront team for facilitating this webinar, and of course thank you to you for attending. Thanks for giving up an hour to listen in, and we'll hope to see you on the next webinar conference. Thank you very much.
Thanks, Rob. Thanks, everyone.
Thank you.